So hello everyone. This is our new, let's say, a course, mini course, let's say, in the club about a small dive into AI. It's, as I said to the people who are here from the start, it's a small, nice introduction to what AI is. We will just see the basic ideas, how to apply AI without really indulging a lot in the math. So in the math, you can keep it for your classes or for if you want to really get indulged, I can recommend some courses, or we can have something even more on this, like some extra events about it. But today, let's just start with a brief introduction on what is AI in the first place. And hopefully it won't last long for just like 45 minutes, 30 minutes, something like that, just to give an idea. And then at the end, let's have a small, let's say a homework, not really a homework, just a small fun thing to start up your own project of an AI that you can add to your CV as like you have created your own first AI. It's going to be simple, not too hard, not something really hard. So let's start into it. So what we'll cover today is what is AI, machine learning, what is machine learning, because you always hear the word machine learning, but exactly what it is, not the definite, not the mathematics, because it's a huge field, but let's see like better idea on what it's going to be. And then the pipeline of AI, the importance of data, because today we're going to focus on how to collect your data and get good data. And then we start with creating your first AI and the challenge of this week for you. So what is AI? We'll go for what's the general definition of it, some history, and then the difference between narrow and general AI, which is the most important definition. You're going to hear it a lot in general. And then the applications and some examples of every day that AI has already been in for a while. So AI in general is just, let's say, a way for the computer to mimic human thinking. And it works in a bunch of ways. These are some of the ways that it works in right now, which is like learning. Like an AI can learn what you're saying based on, let's say, you show them this specific data, this, and that, and then it learns based on this. Or it can reason itself, which is logic. And this might be something that we won't see when you're doing conventional machine learning, but reasoning is something very important that has to be worked on with computer scientists and mathematicians. And that's why you guys would be like in the first year students and the second year students, we covered like the logic and these stuff, because reasoning is very important, and it's not something that you will see ChatGPT, let's say, very good at still. It's good, but it's not as good as it should be for it to be like something super powerful. And then self-correction, which is kind of similar to, let's say, how an algorithm propagates to go back and then correct itself and so on. So that's basically the idea of AI right now, just a computer that can think, that can reason, and that can keep correcting itself, right? Not think, learn, basically. But yeah, that's the general idea of it. It kind of mimics humans, but you want something that's even better than mimicking humans. But most of the things that you will see is basically built upon mimicking humans. The general idea of it in the beginning was mimicking neurons in the brain, and so on. So let's go in a small brief history of AI, and just that's the timeline. I'm not going to go much in depth into it because I believe a lot of this stuff, or you can go through it yourself, but you don't want to waste a lot of time on this old stuff. But let's say in the 1950s, we have like Alan Turing, very well renowned mathematician, one of the largest computer scientists in the history. He kind of gave a new concept of what AI is, and generally made the imitation game give somehow a definition for what AI should be. Like we can see back then, I believe the many of the students here have taken the imitation game and what it is and how you can have an AI, which is, let's say, the idea of it basically, he said that an AI should be something that can trick you into thinking that it is a human. So a way they would do this would be like, let's say you'd be in a room and then the AI would be in another room, and then you'd ask a question and you get an answer, and you have to determine based on this answer if the person in that room is an AI or a human being. And that's the imitation game. That's kind of give us an idea on what artificial intelligence could be, what the whole concept of it can actually be in the future. Of course, that was kind of the building blocks of it. And up until today, the imitation game is one of the best tests we have to determine how good an AI is into, like, let's say, tricking you into thinking it's a human. So that's the idea of reasoning, and learning. So it's a thing that you think can actually think and understand, just based on questions. And then we had the first chatbot, Elisa. That was also done in 1965, which is the most basic format of it. Not really doing so well on it. And then 50 years later, we saw how good chatbots can get if you apply the right technology and the huge amount of data and the right data for it. Then we have in the 1997, by the way, between these years in the 70s to the 80s, there was something called the AI winter, where people just kind of stopped researching AI for a reason, and wasn't as trendy as it is now. Of course, it's like a hype thing, but then AI started regrowing again when we gathered a lot more data, and all of the technologies that were not the technologies really, the algorithms and the math that we had prepared before that, finally found a chance to grow with more powerful computers and a huge amount of data. In the 1990s and up until now, of course, AI started growing again with internet and so on. It started growing like slowly again. And it started with them in 1997 with IBM showing how can an AI reason so much that it can win in chess. And that, of course, because it just needs a lot of thinking and a lot of reasoning and a lot of critical thinking, let's say. So it's based on these rules and how can it apply these rules. It managed to win in this game. Something in the chat. Oh no, it's just from before. And then in 2009, Google started with its own self-driving cars using AI again. But that wasn't the first time to use AI. There's an AI that it's popular, and we're going to talk about it when we get to the models of AI. It's called Perceptron. It was used also to kind of self-drive, not really self-driving, but then you have actually self-driving cars. But that was like, I believe, in the 90s as well. I'm not sure, but a university, I think MIT, if I'm not wrong. And then we have AlexNet, which was the first big jump we had in computer vision and the convolutional neural networks and so on. That was a huge jump because if AI can see, then it has jumped a huge jump in where it can go. And the whole image thing, it's very, very huge in any field, of course, because it can cut a lot of ropes and a lot of, let's say, steps in the future to make it so much better that you can imagine just showing something to a computer, the computer trying to analyze it, understand it, and give you ideas about it. And that's like, I believe also, it wasn't the first thing that OpenAI did when they released ChatGPT. So you can find it all in GPT-4, the premium version of ChatGPT. You can find the vision idea. But nonetheless, it existed from before, and it's more of a narrow application. So we're going to see what narrow is. And then in 2017, there was the biggest paper, let's say, probably the biggest paper in our century that was released, Attention is All You Need. This paper was the idea of where transformers came in, which is a thing that allowed stuff like OpenAI to create ChatGPT and this kind of stuff. So that was the moment that kind of changed history. Just the releasing of this paper by Google engineers, and I believe, I think Google engineers were the ones who released it. Ironically, now it is the weapon that's like, it was used to start, let's say, this whole AI revolution. Everyone now is using it. Bard is using it from Google, ChatGPT. All of these companies are using transformers from there. After we look down the history of AI, let's go into our current definition of AI. Right now, what we have of AI is called narrow AI, which is AI that's pretty much works on just creating one specific task, like Siri or Alexa or these stuff. They have a very specific task of listening to what you're saying to them and then just doing it. And usually it's just limited to their operating systems on the phone. Like when you have Alexa, you just say, well, not on the phone, Alexa, let's say, the technologies you allow it to control and that it's programmed to control. So it's not really general as some people thought it would be. So it's not as powerful as you'd expect it or you think it should be. And you have image recognition software. Let's say it's a specific app that's built to identify if this fruit, it can show you what is it called? Let's say if something's if the fruit is bad or not, and you can eat it or not. So that's something very specific. And chatbots in general that we have been seeing in the last, not in the last few years, but from before. Like, let's say you open a Teams application and then you have the chatbot there. It's an AI that just can help you with the stuff that's related to the company itself. So that's narrow AI. It has one specific task. It can just do one specific thing. Not really very smart. You wouldn't call it an AI, but it is like kind of an AI because it does reason a little bit based on its own specific field. Then we go to the aim of almost every AI engineer in the world, general AI. General AI is the idea of having this one AI that can know everything and can surpass any human in anything, in any field it has. And it can, let's say, ask you a question about medicine, gives you an answer. A question about this, gives you an answer. ChatGPT kind of does that. Sam Altman was talking about it a few days ago. He's saying 10 years ago, probably people would have considered ChatGPT general AI. But later on, you think about it, it's still not as good as everyone is in the field. Like a human could surpass it in a lot of fields, especially if they have a lot of, let's say, expertise in it and can reason and can use logic a lot. It is the dream. So for everyone here, this is what we want to reach. But then again, it's also it has the risks of it and so on. So you have to also be responsible before we create something like that. Now let's get to just a few examples, which you can see here on the screen of AI in our daily lives. Because AI already exists, and we can see it all over the place in virtual assistants and like Siri and so on, as we mentioned earlier. Recommendation systems. When you open Netflix and you see a movie that's like recommended for you, more likely than not, it's like AI that determined an AI algorithm that determined it. Could be also data structures and so on, but AI generally now is helping much better in these algorithms like TikTok and these kind of stuff. Then we go to image and speech recognition, of course. I think you're familiar with it sometimes when you get people ranked, in Google Photos, when you open it and then you find people, this, and that. This is usually, what do you call it? Like AI has already recognized these people, clustered them, which you're going to see again now in the future, and then it did it. So these are all like ideas of how AI, you can see fraud detection in banks and so on. Health and fitness, it's very important because it's already being used a lot. And it's where revolutions are going to happen because AI will help a lot to prevent huge accidents, let's say, well, not accidents, but in reality, a lot of issues with medicine and so on in the future. So this is like summary of some ideas that the AI can do. And now let's go into actually trying to understand the technology behind this. Now we've got the idea of what is AI in general, how it's applied in our real life. Now let's see just what it is. The most big part of AI is machine learning. This is the thing that's, let's say, what defines AI today. It's the trend of AI. It's what the bulk of AI is. It's called machine learning. Machine learning is, as the name says, teaching the machine how to learn new ideas and predict and generate and so on, just by these small ideas. You can see a bunch of types here: supervised and unsupervised learning, deep learning, and reinforcement learning. In our course, we will focus on deep learning, unsupervised learning, and supervised learning. We start supervised, unsupervised, and then deep learning because deep learning is the more complex part. And even in our course, you take it after the machine learning because it is part of machine learning. FYI, just because many people didn't know that, but it is actually part of deep learning. Is part of machine learning. We'll talk about this later in detail. So the first type of machine learning is supervised learning. Supervised learning, you basically have a huge amount of data. Let's say pictures of apples and oranges, okay? Or let's say cats and dogs, like the example is here. These cats and dogs, let's say you get a million pictures of them, 500,000 pictures of cats, and 5,100 pictures of dogs. And then you say, okay, this is a cat, it's a cat, it's a cat, it's a cat, and keep just labeling them all. And then you label all the dogs. This is done by a human, it's manual. And then after that, you can give it to the AI. The AI understands whichever algorithm it uses. We're going to talk about the algorithms and the models. They're called models in AI that it would use to know what's the dog and what's the cat, even if it's never seen that dog or the cat, because it learns over these pictures. It does need immense amount of data, but not a million. Like you can do it with 100 amount of data, but the more the merrier. It's always the more data, the better. Most of the time, quantity usually surpasses quality, but not really. Depends. But that's in general what is supervised learning. You already have everything labeled, and the AI is basically learning from these labels. Okay, and then we go to unsupervised learning, which is let's say a cooler idea of AI, where AI can learn from data that hasn't been really labeled. It can just notice patterns that humans haven't noticed. Let's say there's one of the most famous one is clustering. Clustering is that it sees a bunch of data, you just throw a bunch of data on it. It starts noticing that, okay, these data are kind of similar to each other, so it just puts them in one part, and these data are kind of similar to each other, so another part, and these data are a bit similar to each other, so it just clusters all these data. So that's clustering, let's say, and that's in unsupervised learning. You didn't tell it these are the clusters, but it notices similarities in the patterns, and it clusters them based on that. And then you have the dimensionality reduction, or reducing the dimensions of data. Data can come in huge dimensions, especially when you try to do embedding, which is something you'll see later with natural language processing. It can take all of this data and just makes it, let's say you have got 10 rows, 20 rows of data, and takes it and just puts it in all in, columns, 20 columns of data, and just takes it and puts it in one column and so on. And it's also a way that it notices what's important here and there, and then it clusters it, reduces the dimensions of the data into, let's say, one dimension or so on. Again, also very interesting, but we're going to see it in detail more later. Some of the famous algorithms, that's just a little, that's nothing basically from like these three examples are prominent, but they aren't the whole thing. Here we have the decision trees. Decision trees are more like, let's say, you give a lot of data, and then it starts creating smaller trees, algorithms of smaller trees, saying, okay, yes, no, yes, no, yes, no, and so on, until it gets to a point where it can make something like voting on what is the most likely outcome based on these specific trees. This is a decision tree, for example. There are other types of it, like the random forest, and they're all similar into a kind of a way that it helps when data is very random. It can help a lot finding these specific patterns, which is nice for weather prediction, for this stuff. Neural networks, that's a type of deep learning, which is, again, a subtype of machine learning. Neural networks are kind of the interesting, in my opinion, it's my favorite part of AI. Neural networks are just a huge linear algebra formula that can take in many parameters. It has a lot of parameters and takes in a specific amount of data, runs it through a lot of formulas, and comes out with a yes or a no. And like it's thousands of formulas and millions, and even in the cases of big companies, billions of data or trillions with the GPT-5, as I think so. I think it's about a trillion parameter. So it's billions and billions of formulas that it runs it through to just get you one answer. It's a beautiful way to do it, and you don't do the math at all yourself, of course. It uses a lot of calculus, a lot of linear algebra, and it does the math for you. Well, you will see the math if you take the courses in the university, if you're taking the AI courses. But here we're not going to go into the math itself. We're just going to go into the practical part of it. So it's a beautiful thing that you can have these equations that can give you a very good prediction of what a neural network is. And then clustering. Clustering is one of the part that I explained a little bit ago, that it just finds similarities in the data and clusters them all into one place. And there's a bunch of algorithms for it, and we will see them again more in detail when we get to the algorithms part. But it's not just about this algorithm that does it or that model. There's something much more important here at play, which is the data. Data can be a very important part. Well, actually, let's go into the data in a second. Before we go into the data, let's go through the pipeline. And so the models aren't just the only thing that plays a hand in the AI. It's the data and even like the evaluation, the human evaluation, the engineer's evaluation. So let's go through the pipeline in general. You get your data, you collect it, you go through the data to clean it up, to make it nice, make it look nice, make it look feasible for the AI. Then you split the data into training and testing. That's not important for now. We can look into this in a second. Then you go through the model selection, which is the algorithms that we showed like a few seconds ago. You choose which algorithm would be most suitable, or you can just try a bunch of algorithms if you have the computational units, let's say, that can allow you to do so. Then you train your model on the data. So that if, let's say, in the neural networks, you have a bunch of functions, it's parameters, but each parameter is multiplied, that's based by a number. So you need to know what number it's going to be multiplied to. It's just the weight. That's what we call it, the weight. And so with this weight, you want to know what it's going to be. This part is the training. And then after you train it, you can get, again, a bunch of this data that the model hasn't seen before, and you see how good the model is going to react to this data, which is the evaluation. If it's all good, you deploy it. Deployment, we might get into it if we could at the end. This is a thing that we haven't really seen in our university, in the University of Pavia. We haven't really looked much into it. And then we go back to the model selection, which is if the model hasn't performed so well, we get another model to do that for us. So now today, what we'll focus on, because I believe we are already like at 7:30 and they don't want to take forever, like I want to have another 15 minutes. And then we open it also for questions, or if you want to look into some data together, you can do it. Data collection, which is the kind of one of the most important parts, because if you choose a good source of data and it looks good, you will guarantee having good results. No matter, well, it depends, of course, on the model you choose and the data you have, but it will help a lot making the results look good. So why is data so important? Data basically is what creates everything. If you put in some, let's say it's called garbage, into the model that you will use data on, the garbage will come out. It's just organized, let's say, sorted, or it can predict garbage. Let's say the big problem with it, for example, is discrimination and this type of stuff. Let's say you put data from the last 100 years, and let's say there was laws that discriminated against certain people. The data will automatically discriminate against them because it learned from data that was bad. So this is a thing where you have to find the good data and make sure there's no biases in the data. that would ruin the whole thing. So this has a lot of steps included, and these steps have their own tinier pipeline. Before, let's look into the pipeline, then we go back to look into how the data set, how a tabular data set would look like. The pipeline of pre-processing. So really someone's journey. Yeah. So the idea of having data pre-processing is that you have the data, you collect the data from many sources, from your company, from a specific data source. You clean the data, you prepare the data, you remove anomalies in the data, you remove stuff that can ruin the data, you remove missing values in the data, or you can keep the anomalies as well, and you can let the data detect anomalies. That's another way of also doing unsupervised learning. And then after you clean the data and you prepare the data for it to look nice, you take the data for data transformation, which is a way of, let's say, you can use the stuff like dimensionality reduction. You can scale the data to make it more feasible for the AI, not to give a lot of biases. Let's say you put all the data, you take them from 100 to 1000 and so on, to make them more normal. That's why actually I put this tabular data here. Let's say in the feature 2, you have 100, then 5, then 4, then 3. You could scale it down so that it's all in the same range. Or we have here, let's say 2, 5, then 1, and then 7. To make them all more similar to each other, you scale them all together. So you get the largest number, you divide it, and then you apply this, let's say, field and range to scale all the data to make the data more in the same, like let's say in a range that can be feasible to calculate. This is, again, we're going to look into it next event when we go farther into the data pre-processing. And then you go into feature engineering and then data splitting. Feature engineering is also finding which columns. That's it. Okay, let me show you this part because I believe it might not make a lot of sense if you don't get the idea of the tabular, how data looks like. More or less, when you get to deal with data, if it's tabular data, because you can have data as pictures or you can have data as a text, which is like what ChatGPT does and stuff. But for now, let's just focus on tabular data. When you have tabular data, which is just an Excel sheet, let's say, of data, it will look something like this. You've got, I don't know if you can see my mouse moving. Can you? All right, good. So you've got here, let's say in the first row, you've got the bunch of features and the target. The features is what the model uses to calculate whether or not the target should be this number or that number or that number. So here you've got up here in the header, you say feature 1, feature 2. It depends on the features, of course. This can be weather, whatever, yeah. Here it can be also the colors, the sizes, and so on. So these are the features up here. And then the target, it's one value usually. Could be multiple than one, but that's more complicated stuff. We're going to look into that later. And for the features, we have this data that's below it, and the data can come in different ways. Either integers, they can come like here, for example, in the target where there are different classes, 2, 3, 1. Let's say this is a class that you can make up, whatever the data is. You will see some, I'm going to show you some real examples like of data sets. And then you have this type of data, which is data in text, which wouldn't make sense for an AI because AI is not going to be able to read words. It just does math. So one of the things that you do, this is, for example, because you have large, small, and medium, which is data that can be ordered. We change them and transform them. This is the part of data transformation, which I'm talking about, into 1, let's say for small, 2 for medium, and 3 for large. So you change them in order because they have an order. It's called an ordinal encoder. This is one of the more important things that you can do for the data. We will look at data pre-processing in the next event, hopefully. And then you've got data that cannot really be ordered. You have a question? What exactly this data related to? This one is just a sample data. I just made up some values. I think I can share my introduction. Yeah, I can. Yeah, in case you want to see the slides, I'm going to send you the link on the chat. Just show me this option now. But this is just a generic data set I just made up to show you the different types of data here. We will look into actual data sets, two examples that I got, but at the end of this part. And then I'm going to ask you to go on a website. I'm going to give you a website that can show you a huge amount of data. And you can just go around whichever topic you want, music, clothes, whatever, and look into the data of it and can do your own AI for it, which we will try to do here in this course as we move on. So in the first features, here we've got numbers. This is easy for the AI, but again, as I told you, to make it nicer for the AI, we can scale them. So here, for example, we've got this number that doesn't look similar to other numbers. Instead of removing it, we can just scale it down so it doesn't affect the algorithm a lot, because this can just get the algorithm be confused. It's like, oh, well, I see always 4 or 5 here, but this is 100. So it lowers the weight for this and makes the algorithm just get confused. So instead of doing this, we can scale it, which is the feature engineering part. You scale the data to make it more understandable for the AI. And then with the other features here, the colors, they don't have an order. So as we said, we can just give them a code. Let's say we make 3 more columns, and you put 0 when it's not blue, and you put 1 when it is blue. This is weird, but it's going to look more into it, which is called one-hot encoding, which is one of the more initial ways of how we did this, but it's also very useful and very nice to be used. Especially like because it gives a nice idea and it cleans up the area for you when you want to do more calculations. And this part is also important for scaling down the data and dimensionality reduction. I'm sorry. And then we go to data splitting. You split the data because when you're splitting the data, you want the data to train on a certain. You want the model to train on a certain amount of data, and then you want to keep just a little bit, enough to make sure that your model can work well on what it cannot see. So this is called the data splitting. So you split the data, let's say 70%, just to train your model, your AI, just to understand, oh, okay, this is how it should look like. Then you've got about 30% at the end to see, oh, okay, take this amount of data. Let's say you've got 1,000 rows. It takes 70% of these rows to learn how to do the math. And then it takes the last 300 rows to test it on it, to see, oh, okay, did it perform well every time? Based on all of these features, did it predict the correct algorithm, the correct target, or not? This is the more standard way of supervised learning, by the way. This is mostly supervised learning. Unsupervised learning is a bit different than this. And then you can handle imbalances when you notice that maybe there's a column that's highly affecting the whole data set. Let's say here, this column, maybe it's highly affecting it, but it's not really, sorry, not the column here, this column. It's highly affecting because let's see, we have a lot of, here we have a lot of 2. This is a class that's appearing a lot. So it more likely or not just predicts 2 and gets it correct. But there are ways and tools, which you can see in data, that can tell you, oh no, be careful. Your model is pretty much biased towards 2, and it's always wrong when it's about 1 or 3. So in general, it's doing well. But in reality, it's not really accurate. It's not accurate enough. And then sometimes when it's like health-related data or so on, it's very important to get this 0.01% accuracy correct. You don't want to mess up a bit because you might endanger someone's life, or like with self-driving cars and so on. So you can handle this imbalance where the small numbers are making some problems. Then you can do feature selection again, which is just choosing maybe this column is affecting the data a lot, and that's a feature selection. Or these specific columns, maybe you should reduce its power a bit, but that's more advanced. And then after you do all of this, you shove it into the model, and the model gives you its predictions. I hope this part made a bit like sense, because we have to go much more in details when we get to this part. Yeah, and so now we go to the next part, which is the data collection. So we have a bunch of ideas when you get to the data collection, which is the first part. I'm sorry, this is the first part. We have a bunch of criteria that we have to look into when we're doing the data collection. We have to have, of course, a problem defined for us, or here in our case, let's say you can define your own problems, because at the end, I want to give you this challenge to make you create your own AI. So I want you guys to find your own data sets online that can allow you to create your own AI. And then we can go over it again next week and create our own AIs. So, but the general idea of it is that we want to define a problem. So let's say you want to predict, I'm going to use this because we're going to use this data set in a few minutes. I'm going to show it to you. So it's nice to show you an example here. The problem that I was trying to solve, I was doing this AI for myself, and I used it also today at the university, was that I wanted to predict whether or not a space mission is going to fail or succeed. And so I had that was the problem in mind. So I defined this problem. This is what I'm trying to do, is predict how if a mission is going to succeed or fail. And then I decided to find data that can be close enough to the problem that I want to tackle. So it was a bit of research, but I used one website, which is called Kaggle, this one. And the link is here. I'm going to send it in the chat in a second. And to see good enough data for the information that I need that can help me a lot in predicting. You don't need to be an expert on the topic, but it's good to have an idea on what data is usually going to help. Don't be also very strict on what is or isn't going to help, because sometimes something that you expected will help won't help, and sometimes the things that you might think, oh, well, that of course that won't help, would be very helpful. So the data quantity, of course, that's important because the more data, the better and the more instances the AI is going to see to help you well predict. Oh, okay, this, and that are plausible. So maybe this case also is important. So it adds up all these instances, which very huge, very large, and then it can give you even better results based on that. The data diversity, as I said earlier, that well, that's the last point, is that you want to give it a lot of instances. You don't want it only to predict, oh, okay, this is, let's say the project that I used, okay, this is an American rocket and the Russian rocket, an American rocket and a Russian rocket. It's just going to get used to, okay, if it's an American rocket or a Russian rocket, it's most likely just going to succeed. But if it's not, because maybe let's say it's a new country, it's the first time they launch, let's say Japan. Japan is good, but let's say for the sake of our argument that Japan isn't so good in space emissions, then let's say, oh, Japan is automatically always going to fail. But it didn't see enough instances of Japan succeeding in its missions. So it wouldn't assume that all the time. So you want to get data that can cover as much as possible of the instances that can happen. And of course, the time frame. When you're trying to solve a new problem, especially if it's something modern, an issue that's modern, climate change, stuff like that, that's modern, you want to get data that's relevant now. That's something that wasn't really relevant 20 years ago. The weather wasn't like that's you predicting the weather, which is another data set I'm going to show you. And maybe it doesn't matter a lot what happened 20 years ago. Maybe it matters a lot what happened the last 2 days. So you want the data of 2 days ago more than you want the data from 10 years ago. And this is a problem that you also might need to tackle when your data gets too large, but you don't have a good computer. You'd have to sacrifice some data. So you start using the more modern data. And so that these are like kind of the five most important ideas that you will need when you're trying to collect your data. So keep this in mind when today when you go searching for a model, keep these ideas in your mind. Then after that, let's go into where can you find some sample data sets. Which, because again, the idea, the challenge of this week is that I want you to go on the internet, on this website, and find some data sets and try to figure out if you can like see if it's a good idea or not. So here we can find this website. It's called Kaggle, and you can find. I'm going to send the link in the chat. Wait, and send you the link quickly. If you have access to the whole the link of the presentation, you can also have access to this website. But anyway, this is the link. And as you can see here, let me see if we can zoom in. I cannot zoom in. But anyway, we've got a bunch of data sets here about Spotify. What were the most famous Spotify songs? And you can, let's say, make an algorithm that can predict what's a good song later. I know some people, some engineers that, but they didn't use AI, I believe. Actually, some of them did. That just did that for their own Spotify, so that they can what do you call it? Like just make it predict the music better than the algorithm on Spotify because sometimes it can be biased. It's just a fun project. You have other one, a customer for customers for shops. That's very important. It's used a lot in supermarkets and these places where they predict based on what you bought. They can predict what else you will buy, and these trends of sales and so on. And these sales are made because of that. Actually, an interesting story. In a supermarket, I think it's Target in the U.S. I'm not actually sure about the market, but they managed to know if a woman is pregnant or not, just based on what she bought. So sometimes they would know even before that woman would know because it's like let's say the woman unconsciously would just buy these stuff, and they would know and start sending advertisements for products for pregnant women to these women without them knowing. Sometimes dad was once surprised seeing this mail come to him, and then no one in their house knew that the woman was pregnant, except that the supermarket knew before they even knew, which can show you just a little small glimpse on how powerful this AI can be in just predicting stuff that humans would never be able to predict. And let's go now into some sample data. And again, you can also go around. This website's full of amazing data, medical, customers, whatever you want. You can just go there. I sometimes just go there and try to look up some fun stuff to work on and get data from there. Now let's go into an example. This is one of the datasets that I use. Let me try to get you the link. Again, the link here. And oh wait, I stopped sharing. Yeah. Right. Let me leave the presentation without stop sharing it. Yeah. All right. with my data set that I used. And let's go take a look at it there in the website instead of taking a look at it on the presentation. So let me share this tab instead. Can you see my screen? Thank you. All right. So this is the data set that I used. It had the index of which flight is it, which flight it's talking about. It had about 4,000 missions. And I really love this data set because it went, okay, wait, I went down a lot. Yeah, let me just get it in the big screen, maximize the screen. I love it because it got a lot of the current space missions, so it was relevant historically. I believe this one is pretty relevant, yeah. 2020. Actually, there is a newer one the one that I used was even newer than this. It was up to 2022. So I found this one. It's also similar to this one. It was very similar to this one, in fact. It talks about which company launched it. It has up until SpaceX, so it's relevant enough, relevant enough. SpaceX, all of these, Roscosmos, which is the Russian space agency, United Launch Association. No, wait, not this one. You have a lot, as you can see, you can go through it right now, and you can find so many companies that launched. It recorded all of it, okay? And then you have the site of where it launched, let's say from the specific country, the specific state, and so on. And it can gather all of this, which is very useful sometimes for a lot of these data. Because, well, the place that launched from, maybe this place can be more likely it's closer to the equator, so it can launch faster and hence more successful than if it is farther away from the equator. Again, you don't need to be a domain expert, but you could just have some knowledge about what makes a launch successful or not. Here, I believe this should be, yes, the time and the date of the launch. I kind of limited the time. I separated them into two new columns, so I put the time alone and the date alone. Because I said, well, maybe if the launch is in the morning, it's clearer skies, weather is different. It's whatever. You can make your own ideas, and then the AI will find the patterns for you. But this is the nice thing. You don't need to know how the physics laws work, but you can predict it better than a physicist could. Well, the AI can, but you're the one facilitating that. Then we go into we can see it. Then we go into the status of the rocket, if it's still active or not. The rocket itself is that if this specific rocket that flew this mission is still being used, not the same specific rocket, but like the type of it still being built and so on, and how much was spent on the project, and if the project was a success or a failure. And based on this, you can determine it. As you can see here, there's a huge imbalance. It's 90 to 10%. So technically speaking, if the AI just guesses, more likely than not, it's going to be right if it's a success. So you don't want that to happen. So you try to limit this whole bias by adding as different ideas called sampling, which we'll look into, that fights this whole imbalance in the targets and the criteria that happens here. It makes it a little bit more diverse and some really nice math. So we looked into that as well later on when we get to it. The other data set that I used, let me go back to the presentation and send you the link again. Actually, in fact, it was my friend who used it. And here we go to the predicting weather, if it's going to rain or not in the next day. This is a little bit hard because it's more random. So this is where you need to be pretty smart to actually figure out your way throughout the data. So let's again go to the same data set. All right. I sent it in the chat, I think so, yeah. Again, the same idea. You've got features, data in the features, and then a target, okay? Here it's much bigger, in fact, than the one from before. It has 23 rows, so that's a lot more. You can go through the location of where the rain happened, the temperature of that day, the maximum temperature of that day, the rainfall in general, in like how big it was in that time, the evaporation around the area, and so on. Like it's a lot of information: pressure, temperature, rain, the rain tomorrow or not, and you can predict also the rain today, like that was recorded. So you can just predict always next tomorrow. Is it going to rain tomorrow or not? We can see some imbalances here, but the data is so much. It has about how many instances is it? Well, I cannot see, but I remember it was more than 1,000, 20,000, something huge, something really big. As you can see, it's like 14 megabytes. It's pretty huge for data only. For Excel, that's a lot. So your computer can sometimes lag over this amount of data, or whatever cloud source you're using won't work because it's so much data that it just takes forever to train a model. So here you have to be smart in choosing which model should stay or not. This data was from 2007, so let's say more or less the rain for tomorrow is not going to depend on 2007, so we limited it to just 5 years. So when you limit it to just 5 years, then you're better off because yeah, maybe the last 5 years there was a pattern with weather, there's something different, so it can predict this. It's very interesting, again, very intriguing. You can do a lot of it. This is a weapon that's amazing. It can do a lot of stuff that you wouldn't believe it's possible. Then now that we saw all of these data, let's now give you the chance to create your own AI in whichever topic you want. I believe, as far as I can see, that we will have weekly meetings, weekly by a week or 2 weeks, depending also on the activity of the classes and so on. So let's say that by a week or two, by next week, as soon as you see us publish a new event, let's start creating your first AI. So what I would ask you to do, if you want to, of course, it's not something documentary for the club members, but if you want to, you can create your own AI here. This AI that you would create is basically, you want to gather the data right now. Your step for now is you gather the data, find data sets on Kaggle about whichever topic you like, and see if it has all the criteria that we talked about. Is it new? Is it enough? Is it a lot? And you can, of course, keep it for now. We can talk about it next session. We can, use it and see it, take a look at it. If you would like to, you can send me in private on WhatsApp or on the group on WhatsApp to discuss to see, oh, that's a good data set. Or what can help? What can be another better data set? How can we make this data set better? And then you can present it next week or keep it, because we can, along the semester, along this year as well, but mainly this semester, we want to give you the chance to create your own AI. So by, let's say, by November, December, the end of December, sorry, before Christmas or so, we want you to create your own first AI. So an idea would be like, okay, you gather the data now. Next event, we go through the idea of data pre-processing, which is the pipeline, the whole big pipeline we talked about. We go through how it actually is, at least up until where it's feasible for us without getting so technical. And up there, you will be done with your first, let's say, part of the AI. And we can see how far it can go. And then you can see your own personal little project, pet project work. I hope that's a nice idea. Yeah, let me hear your opinions about it as well. And by the way, I believe this is also the end of it all, the end of the presentation. So thank you. And by the way, for our members who want to join us, who want to keep going with us, if you want to join the core team, we have the deadline is on the 31st. So please fill up the form that I sent on the group. I will send the link again just today maybe on the group, and you have the presentation with you in case you want to go through it again. You want to determine what's some good data or not. And yeah, do you have any questions with regard to this? Any ideas? Any comments you want to add? Anything you want to add? I believe I have a lot of people here. Please, you can open your mics and talk. Send in the chat. All right then. As if there isn't anyone who has any questions, we can end the meeting here. And I hope you find it fun as a fun starting point to what is AI and the dive that we will take into AI along the next few weeks. And I hope, hopefully by the end you can have your own machine learning project or deep learning project. Can satisfy like a lot in your future, and it help you a lot in understanding what your whole courses and so on would look like. So if that's it. Sorry, I heard some.
Yeah, I have a question. Like, if I take the data set of spaceship landings, and like, I just wanted to. I'm from Russia actually, and I wanted to check, like, to predict the next launch of Roscosmos Corporate, and it will be just like a prediction? Yes. Just is it really useful? I mean.
In reality, I mean, with the one, because I built a model on it, I built a bunch of models, in fact, like 20 models maybe. And then I built my own deep learning models on it just to test what deep learning is. It is impressive. It can work up at 98% accuracy. So yeah, you can actually input the information of the next mission. And I wanted to try to do that with because I'm a huge fan of space, I'm a huge space nerd. I really wanted to do it. Start making a list of all the missions that are going to go, and it is impressive. But more likely than not, it's going to predict success. And now, at the point we've reached in time, more likely than not, space missions usually succeed. So maybe 20 years ago, this would have been very useful. I mean, back then, 2003 was the that was it the Challenger or Columbia, one of them, one of the accidents that happened then. So up until a few years ago, it would have. I mean, up until now, still you've got a lot of accidents that happen, but it's less likely. So the AI, more likely or not, is going to notice the uptrend of safety. It's the same idea of planes and so on. But yeah, it would work. It will most likely. I mean, it will give you success. So yeah, it probably will work.
Okay, but Roscosmos have like around 90% of success launches, and I will just not receive like unsuccess launch from as a prediction.
That is the case right now. I mean, with this specific case, yes, that won't happen because I mean, right now, Roscosmos, I don't believe in the last 10 years I heard about an accident happening from.
Yeah, we just use
Yeah,
like with spacecrafts from USA where like we're really safe.
exactly.
Yes.
Exactly. So that's the difference. Is that I mean, 100 years ago, the accidents would happen almost every space mission, but now, more likely than not, it would be very much safe. Um, so it's pretty much it depends a lot on what you're doing. It depends a lot on the case here, the scenario. I mean, the rain one is more fun because yeah, you can actually play around if you have the right data. You can play around and you can actually see it. Well, oh yes, it was right today. It was wrong. Oh,
Oh,
and but the space, no, most likely, yeah. I mean, you are right. Yeah, in right now, yeah, most likely we'll just get succeed. It's pretty rare for it to fail.
okay. Thanks a lot.
No problem. No problem. Does anyone have any more questions? All right, then. I believe if that's the case, um, let's keep going with this project. I hope you enjoyed the a small event today, and I hope that it's a start of a great series of events. And I hope we learn a lot about AI, and I hope this helps you a lot in the classes that we will take, especially everyone coming from the AI department. And if you're not from the AI department, from outside the university, I hope this helps you a lot in your personal life as well, and your career and so on. Have a great weekend. Well, the weekend's over. Have a great night and have a great week this week. See you in the next event. Bye, everyone.